Question number 100. What is an Ericsson baseband unit? 3, 2, 1, 0. Ericsson baseband units handle digital signal processing, which includes radio signal encoding, decoding and modulation, demodulation for radio access networks. They serve as the interface between the network and radio hardware. Question number 99. How does Ericsson's baseband 6630 differ from baseband 6620? The BB6630 supports higher capacity, with enhanced processing power and energy efficiency, allowing it to handle more sectors and cells than the BB6620, which is ideal for smaller network configurations. Question number 98. Describe the key functionalities of Ericsson baseband units in a 5G network. 3, 2, 1, 0. Ericsson basebands in 5G provide high-capacity processing, beamforming support, and advanced algorithms for low-latency connections, critical for 5 gigaseconds high data rate and low latency demands. Question number 97. What is carrier aggregation, and how is it handled in Ericsson baseband units? 3, 2, 1, 0. Carrier aggregation combines multiple frequency bands for higher throughput, which Ericsson basebands manage through efficient load distribution and advanced signal processing to maximize bandwidth. Question number 96. What is the significance of MIMO in Ericsson Baseband Technology? 3, 2, 1, 0. MIMO, multiple input multiple output, increases data throughput by utilizing multiple transmission and reception points, which Ericsson basebands support to enhance signal robustness and capacity in crowded networks. Question number 95. Explain the term beamforming in Ericsson's baseband context. Beamforming focuses signal power in specific directions, enhancing user experience by reducing interference. Ericsson basebands use beamforming to increase data rates in 5G environments. Question number 94. What are some key troubleshooting techniques for Ericsson baseband units? Techniques include analyzing signal quality indicators, checking synchronization sources, and monitoring real-time alarms for issues like hardware failures or configuration mismatches. Question number 93. How does Ericsson baseband ensure network reliability and uptime? Ericsson basebands use redundancy and failover mechanisms, coupled with real-time diagnostics, to minimize downtime and ensure consistent network performance. Question number 92. What role does Ericsson baseband play in handling network congestion? Ericsson basebands prioritize network traffic, utilizing load balancing and congestion management techniques to maintain performance during high traffic. Question number 91. How does Ericsson baseband support high-capacity LTE networks? 3, 2, 1, 0. by enabling carrier aggregation, MIMO, and massive data handling capabilities. Ericsson basebands are optimized for high-capacity LTE deployments. Question number 90. Describe the baseband pooling concept in Ericsson systems. 3, 2, 1, 0. Baseband pooling allows multiple basebands to share resources dynamically, increasing network flexibility and resource optimization across sites. Question number 89. What are the common alarm types in Ericsson baseband units? 3, 2, 1, 0. Common alarms include hardware failures, signal degradation, temperature warnings, and power issues, each of which requires specific troubleshooting steps. Question number 88. How do Ericsson basebands integrate with backhaul systems? 3, 2, 1, 0. They connect to the backhaul via fiber or microwave links, facilitating high-speed data transfer between the radio and core networks. Question number 87. What is CPRI, and how is it used in Ericsson basebands? 3, 2, 1, 0. The Common Public Radio Interface, CPRI, standardizes data transmission between baseband and remote radio heads, critical for split architecture in RAN. Question number 86. Explain how software updates are managed on Ericsson baseband units. 3, 2, 1, 0. Updates are managed through centralized remote access, enabling scheduled software rollouts without requiring on-site intervention. Question number 85. How does Ericsson baseband handle synchronization? 3, 2, 1, 0. Synchronization is managed through GPS or precision time protocol, essential for maintaining network timing and reducing interference. Question number 84. Describe the role of Ericsson baseband in LTE Pro technology. 3, 2, 1, 0. Ericsson basebands in LTE Pro support advanced features like 4x4 MIMO, higher order modulation, and small cell integration to improve performance. Question number 83. How does Ericsson baseband manage energy efficiency? 3, 2, 1, 0. Energy-saving features include automatic shutdown of idle resources and optimized power usage, reducing operational costs. Question number 82. What is the function of the eNode B in Ericsson's baseband architecture? 3, 2, 1, 0. The eNode B, part of the baseband, handles radio resource management, user data, and signaling protocols in LTE. Question number 81. Explain the concept of cell splitting in Ericsson basebands. 3, 2, 1, 0. Cell splitting divides coverage areas to reduce load and improve performance in densely populated areas. Question number 80. What security protocols are supported by Ericsson basebands? Ericsson basebands support secure protocols like IPsec, HTTPS, and VPNs to protect data transmission. Question number 79. How does Ericsson Baseband ensure seamless handover between cells? 3, 2, 1, 0. Ericsson basebands utilize algorithms to manage cell handovers, ensuring users experience uninterrupted connectivity. Question number 78. What is massive MIMO, and how is it supported in Ericsson basebands? 3, 2, 1, 0. Massive MIMO increases spectral efficiency by using a large number of antennas, supported by Ericsson basebands to boost capacity. Question number 77. Describe the purpose of COS in Ericsson baseband units. 3, 2, 1, 0. Quality of service. COS settings in Ericsson basebands ensure prioritized handling of critical data, enhancing user experience. Question number 76. How does Ericsson baseband assist in managing interferences? 3, 2, 1, 0. Techniques like beamforming, power control, and adaptive frequency management minimize interference in high-density areas. Question number 75. What kind of interfaces do Ericsson basebands support? They support interfaces like CPRI, Ethernet, and optical links for data exchange between radio and core networks. Question number 74. How is traffic shaping managed in Ericsson baseband units? 3, 2, 1, 0. Traffic shaping controls data flow based on COS policies, optimizing bandwidth and managing congestion. Question number 73. Describe the importance of packet inspection in Ericsson basebands. 3, 2, 1, 0. Deep packet inspection, DPI, analyzes traffic at a granular level, allowing enhanced security and COS control. Question number 72. What is an RRU, and how does it relate to baseband? 3, 2, 1, 0. Remote radio units, RRUs, work with basebands to transmit and receive radio signals, enhancing network performance. Question number 71. How does Ericsson baseband support small cell deployment? 3, 2, 1, 0. Small cells are supported by Ericsson basebands to increase coverage and capacity in localized areas. Question number 70. What is self-organizing network (SUN) capability in Ericsson basebands? SUN allows networks to self-optimize, self-configure, and self-heal, enhancing efficiency and user experience. Question number 69. Explain how Ericsson basebands integrate with NFV. 3, 2, 1, 0. Ericsson basebands support network function virtualization, NFV, for scalable, flexible deployment options in the cloud. Question number 68. Describe the backup and recovery process for Ericsson basebands. 3, 2, 1, 0. Backup and recovery involves saving configuration files and data to restore basebands after a failure. Question number 67. What is the role of RF planning in Ericsson baseband deployment? 3, 2, 1, 0. RF planning optimizes signal strength and quality by configuring baseband and radio settings for the best coverage and capacity. Question number 66. How does Ericsson Baseband manage software licensing? 3, 2, 1, 0. Software licenses are managed through centralized systems, ensuring compliance and enabling feature upgrades when needed. Question number 65. What are typical power requirements for Ericsson basebands? 3, 2, 1, 0. Power requirements vary by model but generally require stable, uninterrupted power sources for optimal operation. Question number 64. Explain how Ericsson basebands support VoLTE. Ericsson basebands handle voice and data transmission simultaneously, essential for VoLTE Euro-S high-quality voice services over LTE. Question number 63. How does load balancing work in Ericsson baseband units? 3, 2, 1, 0. Load balancing distributes network traffic across multiple baseband units to prevent congestion and optimize performance. Question number 62. Describe the function of fiber connections in Ericsson baseband systems. 3, 2, 1, 0. Fiber provides high-speed data transport between baseband units and core networks, essential for low-latency communication. Question number 61. What is a baseband processor, and why is it important? 3, 2, 1, 0. A baseband processor manages radio signal processing, encoding, and decoding, enabling communication between devices and networks. Question number 60. How are remote software updates managed on Ericsson basebands? 3, 2, 1, 0. Updates are performed remotely via centralized management, allowing for minimal disruption to services. Question number 59. Explain the concept of frequency reuse in Ericsson networks. 3, 2, 1, 0. Frequency reuse enables the same frequency to be used in different areas, improving capacity without interference. Question number 58. What is spectrum efficiency, and how do Ericsson basebands support it? 3, 2, 1, 0. Spectrum efficiency maximizes data capacity within a given bandwidth, supported by features like MIMO and beamforming. Question number 57. Describe how Ericsson basebands use IPsec for security. 3, 2, 1, 0. IPsec encrypts and secures data in transit between baseband and core networks, ensuring data confidentiality. Question number 56. How does Ericsson baseband support carrier-grade NAT? 3, 2, 1, 0. Carrier-grade NAT, CGNAT, enables IP address sharing, essential for large-scale network address translation in carrier networks. Question number 55. What is the role of OS, Operations Support System, in managing Ericsson basebands? OS enables remote management, monitoring, and configuration of basebands, streamlining network operations. Question number 54. How do Ericsson basebands support handovers in 5G networks? 3, 2, 1, 0. In 5G, basebands support seamless handovers with ultra-low latency, essential for uninterrupted high-speed connections. Question number 53. What is latency, and how is it minimized in Ericsson baseband networks? 3, 2, 1, 0. Latency is the delay in data transmission, minimized by optimizing hardware and software processes within the baseband unit. Question number 52. How do Ericsson basebands use AI for network optimization? 3, 2, 1, 0. AI algorithms analyze network data in real time to optimize performance and anticipate potential issues. Question number 51. Explain the concept of multi-rat support in Ericsson basebands. 3, 2, 1, 0. Multi-rat support enables Ericsson basebands to manage multiple radio access technologies, like LTE and 5G, on a single unit. Question number 50. How does Ericsson baseband manage packet loss? 3, 2, 1, 0. Techniques like error correction and redundancy minimize packet loss and ensure data integrity. Question number 49. Describe the redundancy features in Ericsson baseband units. 3, 2, 1, 0. Redundancy ensures continued operation by duplicating critical components, allowing for failover if a component fails. Question number 48. How do basebands handle emergency calls? 3, 2, 1, 0. Basebands prioritize emergency calls to ensure connectivity, even during network congestion. Question number 47. What is the role of OSS in Ericsson's network management? 3, 2, 1, 0. OS provides centralized management of network elements, including basebands, optimizing performance and troubleshooting. Question number 46. How does Ericsson baseband handle high-speed data transmission? 3, 2, 1, 0. It uses advanced modulation techniques like QAM to achieve high-speed data rates over available spectrum. Question number 45. Explain the difference between uplink and downlink in Ericsson basebands. 3, 2, 1, 0. Uplink transmits data from user devices to the network, while downlink transmits data from the network to users. Question number 44. How does Ericsson baseband support network slicing? Network slicing creates virtual networks with different configurations, supported by Ericsson basebands for 5G. Question number 43. What is backhaul, and how does it integrate with Ericsson baseband? 3, 2, 1, 0. Backhaul connects baseband units to the core network, carrying data for internet access. Question number 42. Describe load balancing in Ericsson baseband units. 3, 2, balancing evenly distributes network traffic across resources, improving stability and user experience. Question number 41. What are key features of Ericsson's 5G baseband units? 3, 2, 1, 0. Ericsson 5G basebands support features like high data rates, low latency, MIMO, and network slicing. Question number 40. How does Ericsson Baseband handle bandwidth allocation? 3, 2, 1, 0. Bandwidth allocation is managed based on cost policies, prioritizing critical traffic. Question number 39. Explain how Ericsson baseband units support IPv6. 3, 2, 1, 0. Ericsson basebands are compatible with IPv6, ensuring future-ready network expansion. Question number 38. What is massive IoT, and how is it supported by Ericsson basebands? Massive IoT involves connecting large numbers of devices, supported by Ericsson through optimized traffic management. Question number 37. Describe the role of network automation in Ericsson basebands. 3, 2, 1, 0. Automation reduces manual tasks, using AI and scripts for configuration and maintenance. Question number 36. What is frequency reallocation, and how do Ericsson basebands manage it? 3, 2, 1, 0. Frequency reallocation optimizes spectrum usage, managed by basebands to avoid interference. Question number 35. Explain Ericsson baseband support for NB-IoT. 3, 2, 1, 0. Narrowband IoT, NB-IoT, is supported by Ericsson basebands for efficient, low-power IoT connections. Question number 34. What is beamforming, and how does Ericsson baseband utilize it? 3, 2, 1, 0. Beamforming directs signal strength to specific users, improving connection quality in dense areas. Question number 33. How do Ericsson basebands support encrypted data transmission? Basebands use encryption protocols like IPsec to secure data in transit. Question number 32. Explain latency management in Ericsson 5G basebands. 3, 2, 1, 0. Low latency techniques like edge computing reduce delay in 5G networks. Question number 31. Describe Ericsson's approach to scalable baseband units. 3, 2, 1, 0. Ericsson basebands are modular, allowing operators to add capacity as network demand grows. Question number 30. What is carrier aggregation? Carrier aggregation combines multiple frequency bands for increased bandwidth and data rates. Question number 29. Describe how Ericsson basebands support self-healing networks. 3, 2, 1, 0. Self-healing allows networks to detect and recover from faults automatically, enhancing reliability. Question number 28. What is the importance of throughput in baseband processing? 3, 2, 1, 0. Throughput measures data processing speed, critical for high-performance networks. Question number 27. How is device mobility managed by Ericsson basebands? 3, 2, 1, 0. Device mobility involves managing handovers to maintain connectivity as devices move between cells. Question number 26. What is the function of load balancing in basebands? 3, 2, 1, 0. Load balancing distributes traffic evenly, improving performance and reducing congestion. Question number 25. Explain redundancy in baseband units. 3, 2, 1, 0. Redundancy includes duplicate components for failover, ensuring consistent operation. Question number 24. How does Ericsson baseband support remote monitoring? 3, 2, 1, 0. Ericsson basebands support remote monitoring through OS operations support systems, allowing centralized oversight of network performance and alarms. Question number 23. What is the role of power amplifiers in Ericsson basebands? 3, 2, 1, 0. Power amplifiers boost signal strength, allowing transmission over greater distances and ensuring signal clarity in radio communications. Question number 22. How do Ericsson basebands support LTE broadcast? 3, 2, 1, 0. LTE broadcast, or EMBMS, enables simultaneous content distribution to multiple users. Supported by Ericsson basebands for optimized data delivery. Question number 21. What is MIMO, and how does it enhance Ericsson baseband performance? 3, 2, 1, 0. MIMO, multiple input, multiple output, uses multiple antennas to increase data rates and capacity, enhancing spectral efficiency. Question number 20. How does Ericsson baseband handle call drops? 3, 2, 1, 0. Ericsson basebands use redundancy, error correction, and optimized handover algorithms to minimize call drops and maintain connectivity. Question number 19. What are some fault management features in Ericsson baseband units? 3, 2, 1, 0. Fault management includes real-time monitoring, alarms, and automated diagnostics to identify and resolve issues quickly. Question number 18. Explain cell breathing in Ericsson networks. 3, 2, 1, 0. Cell breathing adjusts cell size dynamically based on traffic load and interference, improving network efficiency and resource utilization. Question number 17. How does Ericsson baseband support high-speed mobility? 3, 2, 1, 0. Ericsson basebands use fast handover protocols and enhanced signal processing to support high-speed users, such as those in vehicles. Question number 16. Describe the concept of network slicing. 3, 2, 1, 0. Network slicing creates multiple virtual networks within a single physical infrastructure, allowing customized network configurations for different applications. Question number 15. How do Ericsson basebands facilitate software-defined networking, SDN? Ericsson basebands support SDN by enabling dynamic and programmable network configurations, enhancing flexibility and scalability. Question number 14. What is interference management, and why is it important? 3, 2, 1, 0. Interference management techniques minimize cross-cell interference, improving signal quality and overall network performance. Question number 13. How do Ericsson basebands support encrypted communication? Ericsson basebands support protocols like IPsec and TLS, securing data transmission and protecting user information. Question number 12. What is load shedding in Ericsson basebands? 3, 2, 1, 0. Load shedding temporarily reduces traffic or shuts down non-critical processes to manage congestion during high network demand. Question number 11. How do Ericsson basebands support capacity planning? 3, 2, 1, 0. Capacity planning involves assessing network demand and scaling resources to meet user requirements effectively. Question number 10. What protocols are commonly used by Ericsson basebands for data transmission? 3, 2, 1, 0. Common protocols include IP, MPLS, and CPRI, each facilitating different types of data transport in mobile networks. Question number 9. How do Ericsson basebands support Cloud RAN? 3, 2, 1, 0. Cloud RAN separates baseband functions into the cloud, allowing for scalable and flexible network deployment. Question number 8. Explain how Ericsson basebands use beamforming. 3, 2, 1, 0. Beamforming directs signal strength to specific areas, enhancing connectivity and reducing interference in high-density regions. Question number 7. How do Ericsson basebands handle overload situations? 3, 2, 1, 0. Overload management techniques like load balancing, call admission control, and load shedding ensure network stability. Question number 6. What is network orchestration in Ericsson basebands? 3, 2, 1, 0. Network orchestration automates configuration, coordination, and management of network resources to optimize performance. Question number 5. How is Ericsson baseband architecture designed for scalability? 3, 2, 1, 0. Ericsson basebands have a modular design, enabling operators to add or remove units to match demand, ensuring scalability. Question number 4. How do Ericsson basebands support 5G New radio? 3, 2, 1, 0. Ericsson basebands are designed to support 5G near features such as massive MIMO, beamforming, and network slicing for enhanced performance. Question number 3. What is SUN, and how does it apply to Ericsson basebands? 3, 2, 1, 0. Self-organizing networks. SUN enable Ericsson basebands to self-configure, optimize, and self-heal, reducing manual interventions. Question number 2. Describe the importance of latency optimization in Ericsson basebands. 3, 2, 1, 0. Low latency is critical for applications like gaming and real-time streaming, and Ericsson basebands minimize latency through efficient data processing and routing. Question number 1. How do Ericsson basebands contribute to network reliability? 3, 2, 1, 0. Through redundancy, automated failover, and robust error correction, Ericsson basebands enhance overall network reliability and uptime.